Hello everyone, in this video I will show you how to implement modular dialog system in Unreal Engine 5. We will use the behavior trees to drive the dialog flow, which is something special you will not find in any other tutorial. This will make the dialogs easy to create and maintain, and also to extend them with new tasks as you need them. I will show it in my own game, but there is nothing specific to my game. You can use it in your game, and no matter if it's 2D or 3D. So we will start with creation of a dialog system folder where we will store all the objects related to our dialog system. The first thing we have to create is the widget representing the dialog on the screen. So let's right click in that folder and search for the widget, and in the next menu we will choose the user widget. We can name the widget as WB_dialog. Now we can open it and start real work on the widget. So the first thing we will add is the canvas. We are using canvas so we can align other objects on the screen, no matter what the screen size is. Next, we will add the image to the canvas, and we will use this image as a background. So when you are telling some story, you can also use related image and show it to the player. We always want to resize this image to the whole screen, so in the anchors we will choose that option. To really resize it, we have to reset the offset right and offset button to 0. We can also rename the image to the background, so we can access it easily from the blueprint. The white color hurt my eyes, so I decided to switch it from the white to black, but you can skip this step because I will be switching it back in a minute. As a next widget, we will add the overlay, so let's search for it and drag and drop it to the canvas panel. Then we will search for the border, and we will add the border to the overlay, and this border, this will be the base background for our dialog widget. Now we have to change the size and the position of this overlay, so let's click on it and in the anchors choose this one. To resize the overlay to whole screen, we again have to change the offset right to 0. Now it depends on your personal taste. You basically have to change the offset left, position Y, offset right and size Y parameters so they look nice on the screen. After that, you should have the overlay at the right position, and you can switch to border and change the horizontal and vertical alignment so it fills whole overlay. We can now change the color of this border, so let's click on the brush color, and I like the black color and semi-transparent alpha channel. But the issue is that you cannot see the result if you have the black background, so here I decided to switch the background back to white. So let's open the background, click on the color and opacity and change the color from black back to white. And after that we can see that the transparency is visible. Now we have the border ready and we can add more things there. So let's search for the vertical box and we will add it there into the border. Then we will search for the horizontal box and add it into the vertical box, and this will allow us to align the other widgets. We will show the avatar of character speaking in the left top corner in our dialog widget, so we will use size box to define the size of this avatar image. So drag and drop the size box into the horizontal box, and we will override the width and height and set it to 128 pixels because that's the size of our images. Now we need to add the image into the size box, so let's drag and drop the image to the size box, and we can rename it to avatar. Next to the image, we want to show the name of the character, so let's search for the text object and add it into the horizontal box, and that will ensure that it's next to the avatar image. Let's make the text bigger by changing the font size to, for example, 56, and we can also rename this to the character name so we can access it from the blueprint easily. Then we can also change the vertical alignment to center the text so it looks better. And maybe it's also too close to the avatar image, so let's add the left padding to 50 to move it a little bit more right. I think this looks nice, and we can add another row into the dialog widget. So let's add another text block into the vertical box, and we will use this text block to really show what the character is speaking. So let's rename it to the text. We will be changing this text from the blueprint, so we have to check the isVariable option, and we also have to do the same thing for the character name. So let's open the character name again and check the isVariable option. Then we can go back to the text and change the padding to 15 for all the options, so it looks better. So we have a widget where to show the text, and now we need a widget to show the options, and for this we will use the list view. So let's search for it and drag and drop it to the vertical box. Let's click on it, and we will rename it to responses because we will show the responses there. For the list view to work, we need to create another widget which will be shown inside the list view. Let's go back to our DialogSystem folder and add new widget blueprint there. And from the menu, we will choose the user widget as before. And we can name the widget as WB_DialogResponse. We can then open this widget and it will be quite simple. We just need a button there. So let's add new button into the DialogResponse parent widget. And we can rename it to button. So let's just remove the suffix there. We want the response text in the button. So let's search for the text and edit it to the button widget. We will rename it to the response and check the isVariable option because we will be changing this text from the blueprint. Now, in order to show the button in the list view, we need to open the graph and class settings and add new interface there. So find the implemented interfaces, click on the add button and search for the user object list entry. And this will allow us to use this button in the list view. We can now go back to the dialog widget and click on the list view and search for the entry widget class, and we should see the widget there. If you don't see our widget there, you probably forgot to compile it as I did. So let's compile it, and now you can see the dialog response there. And if you click on it, you can see the example of the list view. We can see that the list view overflows our dialog widget. So let's click on the list view and set the size from auto to fill, and now it's correct. It also seems that we can only show the two options there. So let's click on the overlay and we will change the size Y to 400 pixels, so more options fit there. And this is all for the dialog widget, so we can compile it and move to another work. As a next thing, we will create the actor component for the dialog system, where we will display this widget on the screen. That way we can extend any existing actor with dialog system to support dialogs there. So let's create a new blueprint class, and in the next menu we will choose the actor component, and we can name the actor component as a BPC_DialogSystem. In the dialog system component, we will need a way how to start the dialog. So let's add new function there and call it StartDialog. We also need to create the dialog widget, and we can do that in the event begin place. So let's click on it, and we will add a new action there called create widget. For the widget class, we will choose our WB dialog widget. We will use this created dialog widget a lot in our blueprint, so let's promote it to variable, and we will name the variable as dialog widget. Now we can go back to the StartDialog function and add new code there. If you remember, we have the full screen background image in the dialog widget we can use, but by default we will not be using that, so we have to hide it, and therefore we will get the dialog widget, get the background object from the dialog widget, and use the set visibility action and set the invisibility to hidden. That way we will easily hide the background and we will see the game as a default background. Next we have to stop the game because we don't want the skeletons and other enemies to move when the dialog is in progress. The best way how to do that in our case is using the set global time dilatation and set it to 0. That way we will basically freeze the game, but all the other game mechanics like behavior trees, delays or other things like that will continue working. You can also pause the game by using the set game pause action, but this would also pause the behavior trees, delays and other mechanics which we need for the dialogues to progress. Last thing to do here for now is to show the dialog widget. So let's get the dialog widget and call its add to viewport action and call it from the set global time dilatation. So now we have the function to start the dialog, but we have to call this function from somewhere. The easiest way is to create new actor with collision box, and once our character collides with this box, we will start the dialog. In the game you can use such actor to start the dialog when the main character arrives to some area on the map. So let's create new blueprint class and search for the actor. We can name this actor as a DialogActor and open it and add the code there. At first, we need to add the box collision there, so let's click on the add button and search for the box collision and add it there. Then we will add our dialog system component, so let's search for it and also add it there. Now we will open the box component, scroll down and find out the onComponent begin overlap event and click on it. This will add new event, which is executed when some component overlap with this box. The other actor is actually the overlapping component, and we want to try to cast it to our main character, so cast it to the top-down character. If this cast succeeded, we want to call our dialog system StartDialog function. So let's get the dialog system, call the StartDialog function, and really call it from the main output of the top-down character cast. Now we just have to add that newly created dialog actor to the game, and actually to make our life easier we can move the player start closer to the dialog actor so we don't have to walk that far away when we are testing things. And we can add that dialog actor there next to the player start. And if we run the game and move to the way where the dialog actor is, the dialog should appear as you can see here. So this is the first big milestone in the video. We can show the dialog widget. Now we will implement the behavior tree to actually control the dialog flow. We will start by creating the blueprint class for the AIController because the AIController is needed to run the behavior tree. So let's create a new blueprint class and search for the AIController and click the select. We will simply name this class as AC_dialog. Then we create the behavior tree, so right click there, search for the artificial intelligence and click on the behavior tree. In our dialog system, each dialog will be represented by a single behavior tree, so we can name this one as a dialog example. Let's open it, but before talking about behavior trees any further, we need to create new Blackboard, so let's click on the new Blackboard button. We can name it as bbd_DialogSystem and store it in the dialog system folder. Now we can open this Blackboard by clicking the Blackboard button in the behavior tree. In the Blackboard, we can create different variables we will later use in the behavior tree. At first, we can remove that self-actor variable because we will not need it. Instead, we will create a new variable of the object type and we will call it Dialog Widget. And in this variable, we will store the reference to the Dialog Widget, so any task in the behavior tree can access it and change it as needed. That's all we have to do in the Blackboard right now, so let's switch back to the behavior tree and we will continue here. At first, we will add a new sequence here. In the sequence, we will add new tasks and they will be executed from the left to the right. The tasks can be, for example, change of the avatar in the dialog widget, change of the character name, or even some text written in the dialog. So let's start with the first task. Click the new task button and search for the blueprint base because that will be the base class for our newly created task. To make the project clean, we will create new folder for the task. So let's create a new folder and name it dialog tasks. And inside this folder, we will create a new task called dialog task_SetName. In this task, we want to simply get the dialog widget and get the character name text field there and set it according to the input variable we will define in this task. Each behavior tree task has to override the receiveExecuteAI function. So let's click on the override and search for the receiveExecuteAI. At first, we have to add the input variable for our character name. So let's add new variable, set it to the name and change the type to the text. We also have to check the instance editable and expose on spawn so we can change the name directly in the behavior tree. Now we have to get the dialog widget which we store in that Blackboard variable. So let's start with the get Blackboard action. From there we will use the get value as object action. Now we have to cast the generic object to the WB dialog. So let's search for the cast to WB dialog action and add it there. And the get value as object also needs another input value which is called key name, and this is the name of our Blackboard key. So let's use the make literal name as input and set it to dialog widget, the same as we name the variable in the Blackboard. You can also save one action call by converting the cast to pure cast by right clicking to it and searching for the convert to pure cast. And now we can actually use the return value of that pure cast to get the character name text field. And from there, we can finally call the set text action. We will drag and drop the name variable and we will set it to the text because we just want to set the character name to the name of the character from the input. Then we can move things around a little bit and call the set action from the event receive execute AI. Last thing we have to do here is calling the finish execute, and this is needed for all the behavior tree tasks. We also have to set the success to true. If we hit the compile button, we can see that there is an issue. The get Blackboard does not have the target set, so let's fix it. We will simply connect the owner controller to the target and hit the compile again, and now it's okay. So we have the first task for the dialog system ready. Now we have to just call it from the behavior tree. So let's switch back to the dialog example. And from the sequence, we will draw a line and we will search for the SetName task and we will add it there. We can also see that the name variable is there on the right side, so we can set it to the skeleton because that's the name of the character talking in our example dialog. And that's all we have to do here right now. We have the behavior tree, which calls the SetName task, and this task sets the name of the character in the Dialog widget stored in that Blackboard. The remaining part is actually running the behavior tree when we start the dialog. So let's go back to the DialogSystem component and into the StartDialog function. We will make some space here before the add to viewport, and we will call the spawn actor from class here to actually spawn the AIController. So let's search for the ACDialog AIController as a class, and let's split struct bin in the spawn transform, so we will just keep the default zeros as a spawn location, which is okay because it's just virtual actor. We will need this AIController later in the code, so let's promote it to the variable and call the variable as AIController. Next we have to tell our AIController to use our Blackboard, so let's get the AIController and call its use Blackboard. And from the Blackboard asset, we will choose the bbd_dialog. Then we need to set the Dialog Widget variable in the Blackboard. So let's get the Blackboard component and use the set value as object. And as object value, we will simply get the Dialog Widget and connect it there. We also have to set the key name. So for the key name, we will use the make literal name and set it to Dialog Widget, which is the same name as we used in our Blackboard. Then we just have to run the behavior tree. So let's make some space there and get the AIController. And from the AIController, we will run the run behavior tree action. We will have to choose the behavior tree to run, but we don't want to hard code it. So let's add new variable there and call it dialog tree. And the type of this variable will be a behavior tree object reference. We will get this variable and use it as a BT asset input in the run behavior tree. We also need to make this variable as instance editable and expose on spawn, so we can change it from the game view for different actors. So don't forget to compile this code and we can switch to the game view. And here we will click on the dialog actor we have created before, search for the BPC dialog system, and in the dialog tree we will choose our dialog example, and this will be the dialog we will be executing when we get close to the actor. Now we can test it out, and if we run the game and get close, we can see that the skeleton is set there as a character name. It means that our task succeeded. So next task we will be working on is the task to set the text for the dialog. We will go back to our behavior tree and add new task with the blueprint base parent. As before, we will store it in the dialog tasks folder and name it dialog task text. This task will be very similar to the previous task, so we will start by overriding the receive execute AI function and adding the variable for the text, and the type of this variable will be again text. We will set the instance editable and the expose on spawn again, so we can change it directly in the behavior tree, and now we can basically copy paste the code from the previous dialog task set name. There will be a few changes. Instead of setting the character name text field, we will set the text field. So let's remove the character name, and we also have to make the cast pure again because it got reset, and we will get the text field this time from the WB dialog. We also have to replace the name input variable for the text input variable because we have renamed that. And I think that's all here, so we can click compile. And we find out that there's that issue with the get Blackboard again, so we have to connect it to owner controller. And I will keep forgetting this in the tutorial, so be prepared for that. Now we can go back to the behavior tree and draw a line from the sequence and add our dialog task text there. The sequence is executed from the left to right, so at first it will execute the SetName task and then it will follow to the text task. We can click on the text task and type some name into the text variable, which will be used as a text for our dialog. We can now try playing the game, and if we trigger the dialog, we should see the dialog text there. Now we need to wait for the player to choose the response. So let's go to the behavior tree and create again another task from the blueprint base, and we will call this task dialog task underscore response. We will again start by overriding the receive execute AI function, and we will again create the input variable. This time it will be called responses. The type will be text, but we have to choose the variable type as array because there will be multiple responses. We will again need a way how to get the dialog widget from the Blackboard, so let's copy paste this part of a code from our previous task. We again have to fix the cast, so change it to the convert to pure cast, and we need the responses text variable and pass it to the list view in the dialog widget. So let's get the responses array. But so far we don't have a function in the dialog widget which could handle the responses array, so we will have to create one. Let's switch to the dialog widget and we will create a new function here called setResponses. This function will have single input variable, so let's go to the inputs and add new one, and we will call it responses, and the type will be text and the array. In this function we want to iterate over each response and create a button in the list view. So let's start with the for each loop for the responses array. Now it's a little bit complicated with the list views because we cannot just pass the text there. We have to wrap it into the object, and then in the list view we will get it from the object. So let's create new blueprint class in the DialogSystem folder, and in the next menu we will choose the object. We will name the object o_response and open it. And inside this object we will just add the single variable, and this variable will be called response, and the type will be set to text. Now we can compile it and go back to our dialog widget, to the setResponses function. The first thing we do in the for each loop is creating the oResponse object, so let's search for the construct object from class action. We will search for our oResponse object in a class and set it there. Now I found out that we forgot to set the instance editable in the response object, so let's go there, and for the response variable set the instance editable and expose on spawn. We can now click on that construct action, hit the refresh nodes, and the response will appear there, and we can simply set the response to the array element, which is the text of the response we want to store in the response object. Now we can finally store this object in the list view, so let's get the responses list view, find the addItem action, and we will basically get the return value of that construct object and store it in the, or use it in the item input variable. And that's all we have to do in this setResponses function for now, and now we have to open the dialog response. Just to remind you, this is the widget where we created the button and the response text, and which we use in the list view. So we have to click on the graph button on the top right corner, and we will edit the graph here. From the interfaces menu, we will click on the onListItem object set, and this is an event which is called when we set that oResponse object to the list view using the addItem. So the listItem object is our oResponse. Our goal here is to get the response text from the listItem object and set it into the response text field, so it's visible to the player. So let's start by dragging the response text field and using its setText to prepare the action where we will pass the response text. Then we have to get the response from the listItem object. So let's use the cast to oResponse because it's actually our oResponse object. And from that cast variable, we will simply get the response text and use it as an input for that setText action. So we are done here. We have created the setResponses function, which creates that oResponse object with the response text, and we will get this response text again from the oResponse object here and set it to the button. Now we just have to call this setResponse function from the task we have created before, so let's switch to that task. We have a place here to call this function, so let's get the cast output and simply call the setResponses here and pass the responses array as a variable there. I did not realize that I already have responses array there, so I a little bit messed it up here, but yeah, you got the idea. Now, if we try to compile it, we will see that we again had the same issue as before, and we have to connect the owner controller back to the get Blackboard. Just a note here that we are not adding the finish execute function here. We will get to that later, but the finish execute will be called only when the user clicks the button. But as I said, we will do that later. Now we will go back to the behavior tree and we will add this newly created task there. So let's make some space here, draw a line from the sequence and search for the task response and add it there. And because the tasks are executed from left to right, it will be the last task executed in this sequence. We also forget to check the instance editable and expose on spawn options. So let's go back to our task and search for the responses array. Click on it, and there we will set the instance editable and expose on spawn, so we can edit it directly in the behavior tree. Now we can go back to the behavior tree and change the responses array and add multiple options for user or for player to choose from. Once we are done, we can run the game and see how it looks like. So let's trigger the dialog, and we can see the buttons appear there, but I don't like how they look like, so let's change it. To do that, we will open the dialog response widget, go to the designer and click on the button. And as first thing, I would like to change the background color. So let's click on the tint and maybe just make the background completely transparent by changing the alpha channel and setting it to 0. Then we can set the variables in the outline settings to 0. So there is no corner visible for this button. And we might also go to the hovered part of this button and change the tint there and make it a little bit darker. And do the same thing also for the outline settings. So let's change the outline color and also make it a little bit darker. Now we can compile it and see how it looks like. So let's play the game again, trigger the dialog, and I like this much more. So now we can show the responses to the player, but the player cannot choose from them. So let's work on that. We will go back to our dialog widget to do that. We need some way how to inform the response task that the player clicked on the button and that he chose some answer. To do that, we will use the event dispatcher. So let's click on the event dispatcher sections to the plus button and add new event dispatcher. We will name the event as onResponse, and it will have single input parameter. So click on the new parameter and name the parameter as response ID, and the type will be integer. And it will be simply the ID of the response from the responses array. Now we will open the response widget and we will call this onResponse event when the user clicks on the button. So let's click on the button and add the OnClicked event. We want to call the onResponse event here, but the event is in the dialog widget. So we have to access the dialog widget from the dialog response somehow. And the easiest way how to do that is probably pass the dialog in the OResponse object. So let's open the OResponse object, add new variable there, and we will call it dialog widget, and the type will be wb_dialog. We also must not forget to check the instance editable and expose on spawn options, so we can edit these settings. While we are here, we will also add another variable called response ID, and the type will be integer, and it will be the ID of the response from that response array. We will also make it instance editable and expose on spawn. Now we have to set these new variables, so let's go to the dialog widget, and in the construct of response we will click on the refresh nodes, and those two variables will appear there. For the dialog widget we will use this self-reference, so let's get the self-reference action and connect it there. And for the response ID we will simply use the array index, which is exactly the response ID from that responses array. Let's go back to the dialog response widget to our OnClicked event and continue here. We will use the OResponse object in the OnClicked event, so it might be wise to promote it to variable so we can easily access it. So let's do that after the cast to OResponse. We should also rename this variable so it makes more sense. So let's rename it to response object. Then we can get this variable to the code and get its dialog widget. And from the dialog widget we will call the onResponse event. Next we will get the response object again, and from it we will get the response ID integer and use it as an input variable for that call onResponse. This code ensures that whenever the user clicks the button, there is the onResponse event fired, and on the other side of this event there is a behavior tree response task ready to handle this event and the response ID. One thing we have to do here after the call onResponse is removing all those event handlers from the event. If we don't do that, there would be more and more tasks listening to the onResponse event and the code wouldn't work properly. So let's search for the unbind all events from onResponse and call it here. We also have to set the target, and the target is the dialog widget. So let's copy paste the code to get the dialog widget and connect it to the target input variable. So this is all what we have to do in the widgets. Now we have to go back to the behavior tasks and open our response behavior task. Our goal here is to handle the onResponse event and do something useful with the response ID. So let's start with listening to this event. We will do that by dragging the line from the dialog widget and searching for the bind event to onResponse. We have to call this action from the set responses, and we will draw a line from the event and add new custom event. So click the add event and add custom event, and we will call it handle response. This event will be called once the player clicks on the button in the dialog widget. And we want to do two things here. The first one is calling the finish execute, because once the player chooses the response, this response task finishes and we can go to another task in the behavior tree. The second one is storing the reply ID in the Blackboard so we can use it in the other tasks. So let's add the finish execute action here to have it ready. And we can go back to our behavior tree, open the Blackboard there, and we will add new key here, a new variable there. The type will be integer and the name will be response ID. And it will be where we store the response chosen by the user. Now we can go back to the task and store this response ID into this newly created variable in the Blackboard. So let's copy paste the code to get the Blackboard. And this time we should not forget to connect the target. So let's draw a line from the owner controller and draw it down way to the get Blackboard action to the target input variable. Now we can draw a line from the get Blackboard return value and use the set value as integer action. We will connect it before the finish execute and after the handle onResponse, and we will use response ID as an integer value there. We also have to set the proper name for the variable in the Blackboard, so change the make literal name to response ID from the dialog widget. And we also change the success to true in the finish execute. Now, in case you want to check this code right now, you can add the print function after the finish execute and print the response ID. And if you run the game and trigger the dialog and start clicking on the options, you should see the numbers on the left part of the screen showing you the response ID. And this means the code works. We can see that there is one issue with duplicate entries, but we will get to that later in this video. For now, let's focus back on the responses. We will go back to our task and we can remove the print string which was used just for debugging. Now we will go back to the behavior tree and we will start handling the response here. We will have to select different subtrees depending on the response, so let's add new selector there. And because the selector is most right task in the sequence, it will be executed as last. Then we will add the sequence for the first response. And to ensure we execute this sequence just for the first response, we will add new decorator called the Blackboard. And we will click on it and change the Blackboard key to response ID, because that's the variable we want to check here. And we will keep the key value set to 0 because this sequence should be executed for the first response ID, which is the 0. We can also optionally rename the sequence from sequence string to response 0 to make things clear. Now the next part really shows why this dialog system is so nice. We will just draw a line from the sequence and we will call our task for the dialog task text. And on the right side, we will simply change the text to the answer for this dialog task text from before. To react on the second response, we will simply copy paste this code. And we will do just few changes here, like changing the sequence name from response 0 to response 1 and changing the Blackboard condition value from 0 to 1 because we actually want to handle the second response here. We can also change the text displayed as a response to this player's choice. We must not forget to actually call this sequence from the selector. Now, if we would run this code right now, it wouldn't work as expected. The reason is that after this text task, we are not waiting for the user input. It means that it will jump directly back to the previous sequence and go to the previous text task and then to the task response. And the previous task will override whatever we have changed in the current task. We therefore need an exit task, which will be used as a last task in the tree and which will ask for something like, do you want to ask something else or do you want to exit the dialog? So let's click on the new task and search for the blueprint base and we will create such task. We will do that in the dialog tasks folder, and the task will be called dialog task underscore exit. As we did before, we will override the receive execute AI function. And we can again copy paste a lot of code from the previous task. So let's get the code to get the dialog widget and copy it from some previous task to our newly created task. As before, we have to convert the cast to the pure cast. In this task, we will also store the dialog widget in a variable. So let's get the output of the cast and call the promote to variable. We will also rename the variable to dialog widget to keep things organized. We will use the dialog widget and call the set responses here, and we will hardcode two responses here, but in case you want to make it configurable, you can also add variable for that. But we will use the make array for the responses and choose the first response as I want to talk about something else, and the second response as I will go away. Now we want to handle the response from the user, so we will get the dialog widget and use its bind event to onResponse action. We will do the same thing as we did in the response task, so draw a line from the event and add the custom event, and we will name it handle on response. We now have to check which option the player chose. So let's draw a line from the response ID and use the equal action. We will then add the branch action, and if the branch is true, we know that the player wants to continue in this dialog from the beginning, and if it's false, the player wants to exit the dialog. So for the true part, we will just call the finish execute action and set the success to true. Now we can try compiling that, and we will find out that we again forget to connect the target to the get Blackboard. So let's test this task in the dialog tree. So we can open the behavior tree, and from the response 0, we will add the dialog task exit. And we will do the very same thing from the response 1. So draw a line there and add the dialog task exit. Now we can try running the game, and if we trigger the dialog, we can see that we are closer to the end result. We can change the text by clicking the button, but there is still that issue with multiple buttons appearing there, so we can finally fix that. Let's go to the dialog widget, to the set responses function, and there as a first thing we will just get the responses list view and call its clear list items. And this will ensure we will start with an empty list before setting any responses. If we try playing the game now and click on some response, we can see that the new responses do not appear there and the list of responses does not grow. So that works as expected. What we are missing now is a way how to exit the dialog. So let's do that. We will go back to the dialog widget and we will add a new event dispatcher there, and we will call it onExit. We will fire this event from the exit task if the player chooses to exit the dialog. We could probably call this onExit event directly from the task, but here I decided to create another function to wrap it. So let's create a new function, call it exit, and add the onExit event there and call it from this function. And this is useful in case we would need to do something else in the dialog in case we want to exit it. Now let's go back to the exit task and get the dialog widget, and we will simply call the exit function we have just created. We want to call this exit function in the false part of the branch. That means that the user wants to exit the dialog, and in the end we also want to finish execute, so it's that extra command we will run in the false part. So let's do some recap here. If the player wants to exit the dialog, we will call the exit function, and this function will fire the onExit event. We need to handle this event somewhere, and the best place for that is our VPC DialogActor component and the event begin play function. We are already creating the widget here, so once we create it, we will bind to the onExit function, and we will create new custom event as we did before in the tasks. We can again rename this event to the handle onExit and make a little bit more space there for all the other code. And here we will do the exact opposite of the start dialog. So let's check what's there. We are setting the set global time dilatation, so we will have to restore it. So we can copy paste it from the start dialog and paste it to the handle onExit and set the time dilatation to number 1. Let's check what's next in the start dialog. Next thing is the run behavior tree. So we have to stop the logic for the behavior tree. So let's go back to the handle on exit, and we will get the AI controller, get the brain component, and we will use the stop logic from the get brain component to stop the behavior tree. Then we have to remove the dialog widget from the screen, and to do that we will get the dialog widget and call its remove from parent action. And the last thing is destroying the AI controller. So let's get the AI controller and call its destroy actor. So this is really all we have to do here. We can try playing the game, and in case we will leave the dialog, we should be able to go away and leave. Here we are just overlapping again with the box collision, so like that's something we could fix, but it will not be part of this video. The very last thing we will improve in this video is fixing the way how slow the dialog is. This is caused by the behavior tree being evaluated just once in a while and not on every tick, so we will change it. The trick how to improve it is that in every task we have to override also the receive tick AI. And we will don't do anything there, we will just keep this empty, but simply the presence of this event will ensure that the receive execute AI will be evaluated on every tick. So as I said, we have to do that for all the tasks. So here I do that for the task exit. And once this is done, we can start the game again, and we can see that the dialogues react much more faster now. So this is all for today. It was quite a long video, so I hope someone was watching till the end. And in the next video, we will continue in more tasks for the dialog system, and we'll probably finish it. So thanks for watching, please subscribe if you like it, and see you next time. Bye.